We'll give it another minute or two, just make sure everybody it's going to show up is going to show up. I'm not quite sure why, but hopefully my audio is okay. Normally I hear my ear pods, but didn't want to connect to my laptop today, and I'm not going to fight it.
Loud and clear.
Thank you, Craig. Appreciate it. All right, let's get started. Got all the screens. I think I can actually see the chat. I set up a second monitor on my laptop for work. I always have it, but my personal stuff I never do, and it's a lot easier when you're trying to present. So let's get rolling. Um, Good morning if you live on the West Coast or somewhere close. Um, as always, we're recording these videos. If you need to grab a gleam onto a little tidbit of knowledge that we provided, or you want to look at it later or share it, they all get posted to the YouTube, which is like SRS Clips and More, I think is the name of the YouTube channel. Donna handles it. I just look on YouTube every once in a while and see one I missed. This is our agenda below. Of course, we welcome everybody. Welcome. We talk about a little bit of club business, some events coming up. Of course, we have Robothon coming up. We'll talk about today's presentations and then presentations for the future, the Robothon committee up to date. Then we do a virtual around the room after all of that. So it's share what you're working on sort of thing. Sure many of you, most of you are familiar with that. Anything else? I think there's a couple of videos that Steve provided if nobody's particularly chatty. We've become quite fond of, I don't think I was here last meeting, and I think people are really loving those QR codes. So there's the SRS email address. I think there's another opportunity to get it. You can grab your phone and turn on your camera and scan it if you want to send an email off to the SRS group. It goes to Steve. I think he distributes emails if they have to go somewhere else. You can send something to me there if you wanted to, and I'm sure he'd forward along. We have a little bit of a break, at like 50 after 10 till, and then we go into our presentation. I will not be able to stick around for a post-meeting discussion today. However, if you guys want to have a post-discussion meeting, I will gladly hand over the reins as host to somebody that looks familiar. And yeah, you guys can continue on. As always, mute your mic unless you have something to share. By all means, you can stay off if you are actively participating. Just if you're out there tinkering right now, mute if you can, in case you're coughing or a kid runs by or a robot catches on fire or something like that. There's always I'm looking over here because I see it over here. The Zoom chat, you can chat in questions. I will try to keep my eye on it. I'm not the best at that. Unfortunately, I will try, but definitely post any links or, you guys are always good at posting links. All that information gets copied off and then, unless it's personal information and dropped into some notes in the YouTube as well. So it doesn't die with the group here. We save those for those watching online as well on the YouTube. So, and we put this here for about, I don't know, six months ago. Don't share proprietary information. We had somebody come back and they kind of had an oopsie. I guess they shared some stuff that they weren't supposed to, and we had to go and pull the YouTube video. And I don't know if we edited it and put it back up or not, but we had to pull it because we didn't want to get anybody in trouble. So don't share anything that you can't. Robothon merch is here. I think we have like what, week and a half, 2 weeks, 2 weeks till Robothon. And if you're interested, I should say the outdoor, the late summer. I don't know what the official name is for it, but we have two competitions a year, late spring and then I don't know what you call this, late summer, early fall. But if you want to get your your merch on and want to represent during Robothon, here's a QR code to scan. Leave it up for a second. I got a hoodie, I would say, and I would say that Redbubble is pretty decent. I have bought stuff from them before, and their shirts are pretty solid quality, like definitely better than most. And the hoodie I got was great. It was fantastic. So there's all sorts of stuff you can get it with a variety of different logos. So if that's something you want, scan away. Obviously there's not a huge amount of profit on this sort of stuff, but the money that you do, Redbubble takes its hefty cut, but they do all the hard work. But we do get money for that, and it does go into the account that does things like pay for insurance for Robothon, or if we need some new shares, or I don't know, I don't buy that sort of stuff. But the little bit of money that it does take to run the club, that's where we get it from. We don't have any kind of club dues or anything like that. This is I don't know if I'd call it new. It's been around for a while now, at least got half a year. It seems like it's still going. There's a SRS related meetup launch, and it's called Build It with Arduino. It's on meetup.com. Yeah, .com. Oh yeah, it's right there. Look down below. Donna Smith hosts these things, and it's all robotics-based Arduino programming, so it's very entry-level programming. Um, just because it's Arduino. Um, but yeah, I she meets monthly, and I think it's the week after this meeting normally attends. The next meeting is the 27th, as it shows there. That's the link. Again, another QR code if you want it, but pretty easy to find it on Meetup. If you've ever been on Meetup before, it's kind of like a big database of local events. The maker spaces post stuff on there. A lot of people that do stuff like hiking say, "Hey, come join our hikes," or rowing. I don't know. It's a big hobby like collection point for events. It's kind of fun. I attend one every once in a while. Plus, I post on there for the maker space up north. The Robothon committee. Our next event is October 4th, as seen here. It's again at Sunnycrest Elementary. If you've ever been to the fall event. It's at the same place. It's at the school. It's called Federal Way. It's in the district, I guess. I think it's technically Kent. It's really close to SeaTac too. So, right in that area around the airport, it's like five different cities, like Des Moines, everything connects together. So, but it's in that area. You can just Google it. There is two Sunnycrest Elementaries. One's in North Seattle. If you're north of Seattle, don't go to that one. But yeah, so we have that coming up. Um, Actually, let me grab this Google real quick. Sorry, I want to show you something. Come here. Go back. I'll represent in a second. Just if you've never been to robothon.org, I encourage you to take a look at it. I also do encourage you to go and check out the events. Um, This has not, the robots registered haven't been updated. I know because mine were registered like 2 weeks ago and they're not there yet. But we have an event page. It gives you a little bit more information on it. If you're only interested in certain competitions, you can find out when they are. So if you're only interested in like the build challenges, they're first thing in the morning. Robo Magellan's in the afternoon, and then the little board competitions, ground competitions are right at the end of the day. And then if you've never done it before, here's the contest information. So it's got a bunch of information. It's at a school, so there's like, it's not particularly close to any food. Bring some. It tells you about the different types of courses that we're doing, and then you'll be there's one outhouse there, which is fine. It's like a clean one. We drop it off for just this one event. It's probably the least used porta potty ever when we get it. Um, so yeah, it just be wary. There's not really food around, or you're gonna have to go drive a little bit for food. I might. DoorDash. I don't know. We'll see. But if you do have a robot to enter, please do enter your robot now, just so that we know who's coming and how much time to dedicate to set up. I know there's at least, well, there's mine, and I know of at least one more for Robo Magellan. Is that, can I just slideshow from here? We'll see. Oh yeah, great. You can. Just some additional resources to help you build stuff, make things, get you going if you need some skills. Local maker spaces are great places to meet. Obviously, we meet online. I don't think the online thing's going to stop anytime soon, and I think that because we get a lot of people from out of the area, which is great. We welcome them, and it's a lot more inclusive for those people. It is fun to meet in person. But we have some events, so we'll see. You don't, of course, have to have a robot to attend Robothon. Just show up and enjoy people's robots. And there's a little midday presentation. But I encourage you to check out some local maker spaces if you're looking for a place to make things. Our main Seattle Robotics Society webpage, there's a QR code again for you to scan on your phone. If you go to the resources and then select maker spaces, there's a good solid list of local-ish maker spaces. So if you're looking for that sort of thing, I can test because I participate in one in South Everett, North Linwood, kind of on the border of it off Airport Road, that they are a ton of fun. There's a lot of like-minded people. You build a lot of skills like CAD skills or laser cutting or, um, milling things, that sort of stuff. So we also have some other resources there, just SRS resources in general, like places to buy robotics parts and whatnot. Yeah, wouldn't I actually I don't even buy half my stuff on Amazon for robotics just because there are a lot of great vendors out there. And the Amazon stuff is usually like the bottom of the barrel cheapo stuff. So if you're looking for good motor drivers and stuff, you're probably buying it from somebody like Basic Micro or um,
Mm,
O-Drive or something like that.
mm.
Um, yeah, as always,
No.
we only have a couple presenters. I think the next slide shows it if I remember correctly. Um, but we are always looking for more. Of course, if you want to chat some ideas in, that's fine. But I do encourage you to send an email here off this QR code or just to Seattle Robotics Society at gmail.com and make a recommendation for a presenter. We really would love to hear about your robots, Craig. Just joking. But if you have a robot to show off, even if it's just in a design phase, it's really fun to hear about your motivations, how you organize your project, like what kind of decision making you've made, or that sort of stuff. It's always fun to see what somebody else is working on. It definitely gives a lot of ideas. Me and a couple of my friends will get together and we'll talk about robotics. And I'll tell you what, every time we have a good long discussion about robotics, I make a change to my robot or decide to go in a little different of an idea because they've had some idea, that's really good. Of course, there's plenty that I'm like, yeah, whatever, I'm doing it my way just because
Oh,
I want to learn something. But there's a lot of opportunity out there to, if you're willing to share your ideas, I'm sure people would love that. So there's a couple other options here presenting one of your projects. Like I said, leading a facilitated topic discussion, topical, that's an interesting word. Leading a discussion about robotics in some way. And then, of course, just leading a discussion with a series of interesting videos you've collected. Here's some possible open discussion topics. It's the same list it always is, but if there's something that resonates with you and you're interested, again, email. Steve would be happy to put you on the meeting. I think the next one is like, I don't know, it's coming up. It's like March or something like that. Oh, it's right here. So it's January. Uh, Today we'll present the two gentlemen here that are talking about Bagel AI for robotics. But in the future, Lloyd's got one, choosing the right programming language for your project. That should be pretty awesome. Um, NEPI, NEPI, for smart hardware dev and integration. It must be an application or project management or something. Don't know what it is. Bob Higgins is going to do more computer vision data
Yeah,
processing, which is awesome. Thanks,
there
Bob.
you go. Go, go,
And then
go.
January, Terry James is no, I'm just joking. Terry. So, anyways,
It's like, what?
yeah. Sorry, I was just joking. We definitely are looking for some slots for next year. So
Mhm.
please, please reach out. Next month it's the same bat station, the paint, same bat time, the same Zoom link, etc. So as always, recordings are posted to YouTube. I don't know if they're posted on the website. I've actually never checked that, but definitely on YouTube. Check out the website for more details. Check, we have a merch link if you missed it, and you're thinking, I do want some Robothon socks. Well, they're there for you. Um, Please, as always, help us find some presenters and send any feedback to that Seattle Robotics Society at gmail.com. And then even if you chat them in, Steve does a really great job of checking that. I've actually put in notes that I meant to talk to Steve about. I just didn't get to it, and he read he's like, "Hey, I saw your note in chat." So he does take the time to read through the chat if you're gonna send something off to Steve, like less Charles, more Lloyd, whatever your recommendation is. Um, the presentation coming up later today, it looks like the two gentlemen are online. We'll introduce them when it's time coming up, but they're going to talk about Bagel. I have never seen that word, agentic tools for physical AI. It sounds very interesting though. Look forward to that one. They even have a GitHub, so we'll introduce you gentlemen here shortly. Well, at the end of the hour. All right, we've come to the round of the web portion. Um, so as always, I will stop talking shortly and encourage you guys all to bring something up. We do have a bunch of videos here. Apparently, I've watched one of them, um, or many of them except for one. I'm not sure, but we'll wrap up around yeah, in 30 minutes or so, and then we'll break and then turn it over to our presenters. So come off mute and share. So shy. Okay, I'll share mine since I don't want to start clicking on YouTube videos yet. I get after my kids for procrastinating, and I do it myself sometimes, a lot of times, especially building robotics. Because, I feel like we have two building seasons a year. We have the winter season where you're building for the spring event, and then you have the summer build season, which is shorter, where you're building for Robo Magellan. And yeah, that one is always a challenge for me because, summer vacation, all that stuff. But I decided to, for some reason, Terry was very gracious and ran my Pop Pop 4 for the Seattle Build Challenges 1 or the SRS Build Challenges 1 during the spring, which Terry got a win for me, us. I'll say us. Terry got first
Yeah.
place.
Yeah,
Um,
my part was really hard. I had to push the button and watch it run
you had to pull the trigger.
and hold the trigger. That's
It's
right.
like two things you had to use both your hands.
Yeah.
So I don't know why. Like if you ever saw that robot run, I was not happy with like how much the wheels moved, like the bearings in those motors, those geared motors were terrible, even though they were like a Pololu motor. I don't know if that was my fault or not, but they had been around for a couple years because that was Pop Pop 4, which was 2018 or something like that, something like that. And it had run plenty with like I have it an RC mode on it. Specifically, I knew these are autonomous robotics, of course, as you guys all know, but I have an RC mode just so that you can like hand this off to the kids and say, have fun, kiddos, and they go in there and do a light little bashing. And of course, my own little kiddos help me beta test, even though I don't ask them. But they definitely rough it up. So I decided to rebuild it because I wanted it to be suitcase sized. I travel a fair amount for work. So I ended up rebuilding that robot, which is a terrible decision, but that's just what I do. You guys know. And so I ended up rebuilding it into this little guy. Am I connected? Oh, I'm connected by a USB cable. So this little guy is now suitcase sized, and its name was Scooter. Of course, you guys know, well, some of you know my robots are named after Muppets. And so this one's Scooter Mini because the other one was Scooter. It's basically the same robot. So I've just dumped four months of hard work into rebuilding the same robot, but it's different because it has two controllers now. I don't just use the art. I wanted to do some other things like the build challenges, and it did like the pop can challenge, like part of the course. So now it has like the Arduino Maker Zero, which is the only Arduino I can find that can use the library other than like the 328Ps. That
Hmm.
well, it can use the RoboClaw library, and the RoboClaw is this guy here. This is a 7 amp RoboClaw motor driver. They work great with the Pololu motors that have encoders on the back side of them. These are kind of expensive motors now. Like they used to be like 30 bucks, but I think I had to give like 70 a piece for these things. That's 140 bucks a motor. It was kind of rough, but made worse decisions than that. But yeah, they're that basic micro company that makes those RoboClaw. They they haven't updated their library, or they don't work on our like RP2040s. I do like using RP2040s for things because they have two cores in them. But anyways, I've got it pretty much back to where it was at. I've added some other features on it, so next time Terry runs it for me, well, next time I run it this event, it will be even more accurate, I hope. Not that I was having a problem. I wasn't competing against too much out there, but I definitely wanted to up my game and not bring the same robot. I also have so that one's almost done, and I spent so much time on that thing, which is silly because, the robot was fine and it did what it needed to do. I also have my Robo Magellan robot, and I don't really want to pick it up because it's like 45 pounds and it's sitting next to me. And that one, what do we got? Two weeks, and I've got like a Girl Scout thing to do next weekend. So I have 2 weeks, and I took a couple days off to try to get my Robo Magellan robot working better. Um, I did add GPS to it this year. It will do. I know like somebody else. There's a lady out there. Her name's Emily. She builds robots too, and she's bringing her robot finally to Robo Magellan. We're bringing it out, and I don't expect to actually touch a cone. Mine's all about does it manage to navigate like the challenges and um, of just like the field. And I think that's valuable in itself. Like I know a number of you have robots that you're still working on, starting in the middle of that aren't finished. And certainly mine isn't finished. Mine won't be winning any things, but there's a lot of value to bringing your robot out just to see if it works on the field. Um, an example was Scooter, the original Scooter. I thought it was, no, it was an in-between robot. I don't know what happened to that robot somewhere right now. I brought it out to the field and I thought, no problem, it will go on this grass, but and it'll go out that whatever it was, build challenges two, it'd go out the 150 foot or whatever the setting was, and it will come back. But what I found was the grass at the school was a little taller than I keep my grass and not quite as nice. I mean, it's a school. Why would it be? But I found my robot would like high center out and stop going. And even though I had encoders, it's not going anywhere. So it failed big time. And that was a bummer, of course. But I learned a lot. It doesn't matter. Like I'd highly encourage you if you're just starting out, just build something that will like move and then just test if it can go over some of the traditional like things that get in your way when you're out there if you're building it. I don't think Craig's is going to have any problem with any of the obstacles out there, but again, it's just like going out there with
I don't think mine
a
meets the
45
safety
degree angle
requirements
with
of the
that thing.
I don't think it meets the safety requirements of the competition.
I go bypass those. That thing looks fine. I think yours is that thing electric or Or is it
No,
gas?
it's a gas powered lawnmower.
Gotcha. Yeah, maybe not. Probably not. But yeah, anyways, I encourage you to bring it out, even if it's just to show off. It doesn't matter. Like I've brought robots out that like I cooked the night before and in a hot hurry on accident, just because I was impatient or I was hurrying to try to put something out. And it's still fun to like come out and show off what you're working on and spark some fun conversation about stuff. And we'll uh, we'll remorse with you if you couldn't quite get it done. So I encourage you to go out there, sign up for that, and come out and have fun, ask questions, ask to drive the robot, safety suggestions. Yeah, thank you. Absolutely.
So that's one of the issues that video navigation is good to solve. You talk about your robot getting high centered and the wheel still spinning and the encoder still going. So if you're doing video navigation, that doesn't have an impact on it because the navigation will still tell you where you are.
Yeah, you make a great point. In this case, it was not going to go any further. So even if it kept spinning its wheels, it was just flat high center. But you're right. I could have stopped and seen an error and maybe even got lucky to back up and go around whatever the item that was high centering me. So you're absolutely
Yep.
right. Yeah. Yeah. All right, turn it over to somebody else. Anybody working on something? Seen any fun? Playing with a new module? Which Roombas get high centered cover. Well, that's pretty impressive, James. Getting a Roomba that gets high centered, then recovers and not lose position. I could only guess that it wouldn't lose position because it has beacons. Because those things, well, the older ones, like the 500 series, I don't know about the ones you're using. They didn't have any video. They had like a IR detector that would sense the base. Because
Yeah,
I,
not the 500s and that
okay.
series. They would go up. They would get out of being high centered on their own because they have a wheel that's doing a metric of whether or not the whole robot is moving forward.
Mhm.
That front wheel has like half white and half black, and it watches it and goes, "Oh, I'm turning my back wheels, but my front wheel isn't moving. I must be high centered." And then it'll back up or like do these different, like it has a sequence of different motions that it does
Mhm.
until finally it starts moving again. And then if it's a 500, it'll go off in some random direction. But I think it's the 650 has an IMU with a compass inside of it, and it'll use that and get pretty close to the right one. And then the 900, whatever the latest one is, the one with the camera that's sort of recessed into the top of it that they watch people go to the bathroom with.
Yeah.
That one, um, and they really did, um, at least during the testing. That one will pick up right where it left off perfectly. Continue. It's doing slam or some sort of visual navigation. I'm not 100% certain what, but it's the reason why I mentioned it is because that like just using the wheel to detect that you're high centered and not going forward is pretty easy to do, right? It's just put the wheel encoder on a wheel that's not driven, because every hobby robot puts the wheel encoder on the wheel that's driven, and then it has no clue whether or not it's high centered or not, right? If you put it on the non-driven wheel, then suddenly you can say, oh, something's wrong. And then you can just program in a fixed sequence of, well, try turning the wheel backwards, try turning the two wheels in opposite directions, try, like this one right after the other until you see the encoder wheel move. And then it's like, oh, okay, now I'm not high centered. Anyway, sorry.
No, don't be sorry. You're absolutely right. I think we tend to do that, and you guys call me out if you disagree, but I think we tend to do it out of laziness because they usually come matched on the robot motor, and building an encoder into your trailing wheel or whatever you have is extra effort mechanically.
You hobbyists are so lazy. Whip cracking sound.
Yeah, us
Sorry.
hobbyists don't get 8 hours a day to do it.
Is that what it is?
Yeah.
Yeah, I just to be clear, it's not, I'm never lazy and I never make dumb mistakes. I'm by the way literally on revision 7 of a 3D printed belt tensioner because I just cannot get it right. So yeah, I hear you.
Yeah, if it makes you feel better. I've never printed anything right the first time. It's always the third time that I get it right,
I
it seems.
I would love to have gotten it right on the third time.
Anything else out there somebody wants to share?
I'll share this one. It's not. It's. I suppose it's technically robotics, and it's just the idea occurred to me last night, so I'm just getting the parts together. But I used to race around. Let's see if this will actually come out. Oh, I can't get the camera low enough, and then the blurring kicks in. Hang on, let me turn the blurring off real quick. I had this costume I did many years ago for Halloween, and so it's a robot. And like, yes, it's just a box over my head, but you press the buttons and tell dad joke robot jokes.
Awesome.
And so the kids
Um,
love that. And the only issue was you can see that the two mesh there gave away how I was seeing, and so everyone would like talk to me because like the only way I can see is through those meshes on either side. So last night I was sitting on YouTube and I ran across somebody using this module off Amazon. Yes, it's off Amazon, which is basically a combined infrared camera and lights. And so my plan was to take this Raspberry Pi Zero, one of those servo control boards, and I grabbed I like the wide displays. So
Yeah.
this is touch, so I thought I could put like I have a class for a touch joystick in Kiwi for Python code. So I was planning to have like the screen here and then have controls on either side, and do that up for Halloween. Because I live in a dog box apartment, and so I wanted a costume. Like when I did the previous one with the box, having the arms, actually putting the arms in was really hard, and like I couldn't physically get it off myself without destroying it with the arms because like there's just no way to actually get them through. So the idea was this one: have the box go straight over my head. This here, just have the camera out the front looking around like as an obvious head, so it looks like a robot. Then next year, when I get some more time, I'd love to have it so I have a little door that opens up and sort of an arm comes out with a single piece of candy. You can then let go, and then it retracts back and shuts up, and you can load it again. As I said, it's technically robotics, but I am quite excited about it because like I'm going, that should all work. Raspberry Pi, some servers, Raspberry Pi, a 360, a wired 360 controller. Yeah, it should be fine. Just a box. Yeah, so we'll see if I get it done by Halloween. I'm running a bit short on time, but we'll see how we go.
That is fantastic. That is awesome. Thanks for sharing. Yeah, I love the idea of having the screen inside and everything. You're definitely gonna make people wonder how the heck you're getting around.
That's why I went with the infrared camera because like I was sitting there going like, I could put lights next to the camera, but I'm like, then I'm blinding people. Walking around to be bright enough to see, I'm blinding kids in the face. I'm like, that's not great. And then I saw that all-in-one infrared module. I'm like, oh, wait a minute, that'll do. So hopefully later today there'll be a period when I go into the bathroom with this all wired up in my hands and see how it actually looks on the screen and whether this will actually work. So I'm crossing my fingers.
Yeah, crossing them for you as well. That's awesome. Yeah, 'tis the season. That's totally robotics. Turn yourself into a robot. It is a season for Halloween robotics. I saw somebody at the Makerspace on Thursday working on their Halloween robotics as well. I always have ambitions, but we don't even go trick or treating around our house because there's not all that. There's a lot of hills and all the kids go to the other work places where they don't have to work as hard. But we do that too.
You just need to
My,
send an autonomous robot trick-or-treating for you.
Yeah.
My church is over in Edmonds at Five Corners, and we do trunk or treat for Halloween. So there are some churches that host that, and that's kind of nice because then you're not walking the random neighborhoods.
Yeah. Oh yeah, I mean, totally down. But that we don't walk a random neighborhood. We go to my sister's house, which is in Lake Stevens, and then go walk that neighborhood with my niece. So all our kids are around the same age. So
I, I will say the over the head robot costume, where it's just a box over your head, because I sealed the top with duct tape, so it's really good for when it rains, which happens fairly often. I noticed in Halloween because like you're sitting there going like, well, I'm dry.
Yeah. I can keep going. Do you like, so your hands are inside, do you have to like push the whole thing off now or?
That's the bit I haven't got to yet because I just saw that infrared camera last night and was like, yes, and because like that, so I'm guessing what I'm hoping. Yeah, turn camera back on. What I'm hoping is like to have a sort of like a shoulder harness sort of set up, a control, like basically mount this, mount this in front of me sort of thing with a screen a decent distance away, and then yeah, I'll have to basically just go straight up.
Gotcha.
And so yeah, because like once I had my arms inside the box, it's a standard storage box from Home Depot. It was the one I used last time. So once I have my hands actually inside the box, I could do this. But getting my arms out of the actual arms without like destroying it, I just couldn't do that. There wasn't enough room. So that's why I was like, if I just had one where I like didn't have arms on the thing, I was like, and like so yeah, this year I'm just going for the camera. If I just get the camera looking around, maybe make some beeping noises, yay, done. Then next year, I would hope to be able to do is add stuff to it, like try and keep it so the box can still fold. So I can fold the box up, store it over until next year, and then like pull it back out again, add like an arm, and then it's something else on the front. That's my hope. So we'll see how we go. Even if I can just keep the electronics of the components, so I can just pull them out of boxes and put a new box in every year. That might be an idea.
Sorry.
I was thinking like get a constant velocity motor and do like a radar sweeping on top for no good reason.
Fantastic. So on the screen you're gonna have a little joystick, you said. Is that to move the camera, or are you gonna like move the whole head?
I'm planning to have like mounted out the front a module on servos.
Okay.
And initially it's just going to be like a camera with a cover over it to keep rain everything off.
Yeah.
So very explicitly, this is the camera looking around sort of thing, to give it some character. And so that's my plan. Just a couple of standard side servos. Yeah, should be plenty. Then I hope in the future add like a face to the chest or something for expressions and stuff like that. Just to add a bit more character, or maybe even to the head itself. But yeah, this screen is going to be internal, inside, basically like this sort of thing. So I've got to figure out what's with my old eyes. How close can I have it where I can still see the damn thing?
Fantastic. Yeah. Yeah, you could do that like the Wall-E, the Eva facing notes, right?
Yeah. This year, get the camera working.
Yeah.
Because I've got what was it, about 40 days. So I'm like,
I know all about the freak out fest over. I don't have much time to do what I want.
especially I had looked before and I never saw a module like this. And I mean, it is a bit Amazon quality, because I don't know if you can see. Hang on, let me turn the damn blur off again. It's actually the lights are mounted by screws, and that's all the power bus for the lights. And like in the troubleshooting on the page, it's like, oh yeah, make sure the screws are done up tight, because otherwise it might not start. I'm going, quality. So we will see how good this is. I mean, but they got some light, like there's a light sensors on the front there, which I assume controls the brightness of the IR lights. So because the wiring is just like, there's no additional wiring beyond just the camera bus. It's just literally hook it up as a camera, you're good. So
is it designed to go the Raspberry Pi? Like it's
it's designed.
Harness?
Yeah, it's designed to go with the Raspberry Pi. So that's why I was like, all right, Pi 0. I mean, Pi 0 should be enough to turn around, take enough video and put a display up. So I'm not asking much from it. It's like either it'll be this, where I'm just reading off the analog, the analog sticks to control the camera, or off the screen. And so I have an A and etc. about it, but just like powering those, like when you start, how do I power those sort of things reliably, especially for the period of time? I'm kind of like, let's see if we can get a Raspberry Pi 0 to do this. Like,
yeah. I think you should be able to get the 0. They have the like the RP 2350 or whatever. You can get it modularized from Adafruit, if I'm not mistaken. It does like HDMI output and whatnot. And I mean, that's
Okay.
just a high-end microcontroller. I think the Pi has more cooking power than that. Granted, it's got an operating system, but
So the Mark II, that might be an interesting one because this has only got one HDMI out.
Hmm.
So if I do want to put a screen on the front, it's going to either have to be SPI, something like that, or I go to like a. Does the A? I don't think the A has two HDMI outs, does it?
I don't remember.
I think it's only the 3 that did. The 3 had two HDMI outs, in which case I could just be like screen on the front, screen on the back, and yeah, off we go. So yeah, it will. But as I said, today this year, I am just going for a box with a camera out the front I can move around and like navigate successfully. If I get that far, success.
Sure. Awesome. Yep, you're gonna be wearing a backpack for a battery in no time.
Being there, done that.
Awesome. All right, still got a couple more minutes. Anybody want to share something they're working on or something fun they saw?
This last week I saw a video of someone testing a robot. I cannot remember if it was Boston Dynamics or not, but it was. I was surprised at how it was a humanoid robot. And it was very slender when it comes to the framing and the muscles and the servos, and it was actually they were sparring with it, and it was surprising how nimble it was, and that the guy couldn't knock it over. It still maintained its balance even after being kicked. I mean, he was doing martial arts sparring with it.
Hmm.
And unfortunately, I didn't capture the link on that to shoot it to you guys. But I'm just really surprised at how far the humanoid robots have come. And Boston Dynamics has got a model that is also quite slender, and it makes you wonder what they're using for battery packs, etc., because they don't have these big bulky battery assemblies like you're referring to, like a backpack. Like Atlas, their original humanoid robot, had an enormous frame and a back, basically like a body torso with a backpack built into it, for all the electronics and the power. And somewhere along the lines, somebody has come up with batteries now that you can't tell where they are. That the design is that sleek, and I'm just like amazed at that.
Yeah.
Part of that is the efficiency of the motors has improved, and of the control systems, where they don't necessarily drive the motor constantly. I know a guy that works at Boston Dynamics, and he won't talk about it, but every once in a while I get a little hint in a conversation that I have with him or something. And what he was saying was that the batteries actually haven't gotten that much. I mean, they're getting incrementally better, right? But like there hasn't been a huge advance in that. The big advance has been in the efficiency of the drive system. And then the other thing is, although I do see a lot of really cool humanoid robots out there, I mean, I personally think the whole humanoid thing is a massive distraction, but that's just my personal opinion. But what I never see is any information about how long they can run, right? Like is that a humanoid robot with a 10-minute runtime? Is it a 4-hour runtime? I did see a really interesting video on LinkedIn from a company that was demonstrating the ability of a robot to change out its own battery, and it was pretty creepy. The battery was built like if you could imagine like doors opening on the robot's chest, except that it was the doors opening on the back of the robot in exactly the same like position, like if you could imagine doors on the chest opening up like from an old science fiction movie or something like that. It was just like that, except that the doors were on the back of the robot, and the robot would reach behind itself with its arms. I wish I had saved this video. No, I'm sorry. And the doors would open, and it would reach in and pull out its own battery, and put it on a stand and grab another battery off the stand and put it in. And I think it was like, they didn't really show this, but I guess it was probably connected to a power, like it would back up to the stand, plug itself in so the power would come from the stand, and then it would swap out its own battery. And there were a lot of reactions from people going, oh, this is a game changer, right? Because now you don't have to worry about the battery length as much anymore because the robot can just go out and swap out its battery. So I don't know. I mean, Boston Dynamics is amazing. They're like the only company that I think is really nailing it. There's a lot of others that are doing like really flashy stuff, but I worry about the reliability, repeatability. And when it comes right down to it, you know, you can have a neural network trained, you know, robot in your factory, and, you know, maybe 99 times out of 100 it does the right thing. And then one time it completely screws up the assembly line, borks the machines that it's working, and grinds its parts into the conveyor belts, you know? So I think reliability is more important than people give it credit for.
I keep hearing that Elon Musk is going to be ready to sell his humanoid robots pretty soon. But I haven't actually seen any official announcements. It's all more the rumor mill.
Yeah. And full self-driving is now available, or will be available next month.
Definitely next month. Don't worry. Your hardware is completely compatible.
Yeah.
Well, you have to remember that the original Atlas robot was largely hydraulic, not electric.
Yeah, exactly. So I think
Yeah.
Craig has a video of that robot changing its own battery.
Yeah, that's the link. It's about 3-minute video.
T-Mobile has the best network. That's why they're.
I probably have
Oh no.
ads.
Yeah, that's
Did you
the
guys
one.
hear the
That's not
audio?
freaky looking at all.
Yeah, I heard it for a second.
You heard the audio? Okay, good. Why do I have ads? I'm not logged in. Hold on.
Is that Zoe Saldana there?
No, it's not the log. Let me log in so we don't have ads. This way.
Also in the chat, I threw in a video about it's a humanoid robot fighting league. So two humanoid robots get up and actually box each other.
Oh, yes.
Which actually was quite interesting. What the guy was trying to do there. I was like,
Yeah, that's a lot more of a production video than what I saw. What I saw was like just a single guy in a lab with the robot with enough space to be able to spar with it. And I think they were mostly trying to just demonstrate that he couldn't knock it over. He couldn't get it to lose its balance enough to fall.
Yeah.
I'll play this video here. We got the 3 minutes.
But speaking of Boston Dynamics, my company actually makes a product that integrates on their robot for acoustic imaging.
Ooh. Oh yeah, to be able to hear where a particular sound is coming from.
Well, yeah, it's for catching leaks and arcing in a factory, in industrial environments that are hard to isolate. It picks up acoustic noise from electrical shorts and from liquid leaks, gas leaks. It's a pretty neat instrument, actually.
For the Department of Defense could find another use for that.
Seen before.
Yeah.
It can swap its own battery autonomously. The company says this will help the robots be able to work 24/7 or close to it. The demo begins with the S2 walking and showcasing its 5-finger end effectors, which is just robotics industry lingo for robot hands that don't necessarily need to look like human hands. When the Walker S2 arrives at the battery swap station, the robot suddenly has a different pair of end effectors that seem specifically designed for grabbing and swapping a battery pack. UBTech's robot appears to use 2 battery packs, one on top of the other, to avoid losing power while changing batteries the way BMO does in Adventure Time. The robot's joints appear to be extremely flexible, allowing it to maneuver the old battery out of its back and into the charging tower. This kind of hypermobility in humanoid robots is something we've seen in other robots as well, including Atlas from Boston Dynamics and the G1 from Unitree. Details are scarce about UBTech's latest humanoid beyond this demo, but the company has developed something for its previous generation Walker S1 robots that may help explain how these humanoids could work together in the future to accomplish tasks. It's called Swarm Intelligence, and with a name like that, you know it's what the future. Basically, it allows multiple robots to work together to accomplish a common goal. The video demonstrating Swarm Intelligence shows 2 Walker S1 robots lifting a large object and putting it into position. It also shows one robot handing another robot an item. This demo is very similar to a demo that humanoid robotics company Figure has shared, designed to show off its Helix AI, which features 2 of its humanoid robots collaborating to put groceries away, and another demo that showed multiple robots working on an assembly line. UBTech and Figure are both testing their robots for use in automotive manufacturing. UBTech with Chinese automaker Zeekr, and Figure with BMW. UBTech's robots have also been shown delivering flowers to women and training for what the company says is a robot half marathon. So it's not enough that we have a metallic Mr. Steelio girl to worry about. These robots are also training to be able to chase us down. Perhaps we'll see UBTech's Walker S2 robots at the world's first humanoid robot games being hosted next month in China. If previous humanoid robotics sporting events are any indication, competing robots will be pushed to their limits and almost certainly take some L's. For Walker S2's sake, I just hope they put battery swapping stations along the track so the robots can stay juiced up. You should definitely subscribe to CNET so you don't miss our upcoming coverage of the humanoid robot games.
Well, that's very interesting.
I like that commentator. His little humor that he put in there was pretty good.
Yeah.
And I hadn't seen this video. So the end effector swap, the video that I saw was just, like after it had the one for handling the battery. But I think that's a really interesting point, right? Like they swapped it to a different end effector, which would be pretty useless in a factory for doing anything other than pulling the battery out. So I guess what do they have to do? Like put better handles on the side of the battery to make it easier to pull? Yeah, that's probably a solution, right?
Yeah.
But this sort of thing of like, hey, it's a humanoid and it'll have fingers and it can do everything that a human can be. Oh, wait a minute, we're going to put a different end effector on it. It's kind of funny.
Well, I'm a little confused because isn't that a facet of a lot of industrial assembly is the robots that actually change their end effectors to do different functions that it's like specialized tooling as opposed to a human hand.
Right. Yeah, there could be a stand or something to the side where the robots walk up, drop off their regular hands, put on the robot or the battery changing hands.
Yeah.
Go over and that makes sense.
Yeah, that answered my question. I was wondering how it stayed power. I thought supercapacitors would be a waste of space, but dual batteries make sense.
And I had forgotten that too. I'd forgotten that it was 2 batteries.
I thought that the swarm intelligence was the creepiest part of that video.
Yeah. Get that human. He's over there.
The robot giving a woman flowers, I was kind of like, that seems a tad creepy.
Yeah. What a weird chair.
And I also think a lot of these demos, I mean, I understand that AI is coming along. There's a lot of really cool stuff happening there, but also a lot of these demos are just teleoperated from slightly off screen. Especially that one where the one robot's handing something to another robot, or I think they were standing behind the line or something, and then the way their heads tilt up after they do the handoff, it's a very human motion, and there's like no reason for it other than that they were being teleoperated and the humans did that.
Yeah. All right. We're going to take a break. You guys can keep talking, but I wanted to give this time. And I am going to mess up. It's Arun and is it Shouheng? I'm sorry to butcher your name.
There you go.
Yeah, Shouheng is
Shouheng.
great. Thank you.
Oh no, thank you. Yeah. You guys feel free to set up your video or whatever. Give everybody here 5 minutes to go use the restroom. I'm gonna use that time to go use the restroom when you're back.
Hey, yo, what you doing? What you doing?
That acoustic imager video is just really cool, by the way. I think that's a big advance right there.
Thank you.
Having-
That's a product I actually work on.
Oh, do you? Oh,
As
that's
a service engineer for Flute. Yeah. And that's not the premium unit. That's just the acoustic array that integrates with Spot. That's for static installations, but we actually make a full acoustic imager product called the II 900, 910, and now there's several more models for it that is a standalone that has a visual light camera. I'll put a link in the thing, but it is amazing. It can even calculate the amount of gas or liquid that you might be losing in a leak. It's an approximation, of course, but it's still pretty neat, and it's an extremely popular product. They were, when it was released, it was, kind of trying to see what the market would like in it, and it ended up we ended up selling a lot of products. So now it's a very popular product, and it's only been out for about 5 years.
How much are we for the smaller one? What kind of money are they getting for that guy?
Oh boy, that's a good question. I would have to look up the pricing on that, because I don't have the pricing on that off the top of my head. The acoustic imagers, the full instrument that we make, I am familiar with those, and those run between approximately $20,000 for the
Yeah.
unit.
So
They are.
I can imagine, like, even if this one was $1,000, you put it on a robot, or even if a human walks around with it and just
Mhm.
like carries it, sets it up, points it at something, and goes, "Yep, everything's okay," and then moves on. But the really cool part about it with the robot is that now, like, the robot can know where to focus its attention, right? Like, it can walk up to an equipment bay or something, look at it, go, "Oh, that's an anomalous sound source, right? There shouldn't be a bunch of noise coming from that area." And
Correct.
then go and move closer, if there's a way to do it, move closer to that particular sound source and take detailed imaging, and then send that back to a human that's monitoring.
Yeah, and I'm not sure the the extent to which the Spot necessarily autonomously finds and identifies things. However, that is the purpose of that array, is to give it that capability, and the Spot could even be teleoperated, where it's just scanning the entire environment, and then when something anomalous seems to pop up, then the remote operator can, manipulate the robot to close in on that particular sound or problem. And it's got an acoustic window on it for uh, controlling the audio range of what you're looking for. So you can filter out low frequency industrial noise, for example, and still be able to pick up a lot of different things in the environment. And that's the point of the link I put in there for the acoustic imager. This is a handheld instrument that allows you to pinpoint those noise sources, and you actually take a visual image snapshot of where the noise is happening, and you document it, and then you can use other features on the instrument to calculate the amount of liquid loss or gas lost in the leak. And it also helps to identify, like, when you've got bearings going out in equipment and they start throwing off
right, the noise
noise.
from the
Yeah.
vibration. The other thing I've seen that's really interesting in that area is uh, motion amplification in video, where they do uh, frame subtraction to look at the amount that the pixels are changing between individual frames of video, and then from that uh, compute uh, a way to distort the video to show greater to amplify that motion. I'm not sure if I'm making any sense at all, but the point here is you can have a video feed which is relatively low resolution, and just using the variation in the pixels, it can exaggerate how much something is moving, how much something is vibrating at lower vibrational rates, right?
I'm
So,
gonna ask for a pause and turn it back over to our presenters because they
Yeah.
oh, sorry, yeah,
no
Sorry,
problem.
digression.
Turn it over to them.
Hey there. I'm going to share my screen. Can people see my screen?
Yes.
Great. Yeah, so first off, I wanted to say I know Shouheng is very excited to be talking to all of you because he's based in the Seattle area. And we've talked to groups elsewhere, and he wanted to play a home game for once. So I know that he's especially excited about today. And we're here to talk to you about Bagel, which is agentic tools for physical AI. Now, I know earlier in this meeting, um, the definition of agentic came up, and really, when we talk about agentic tools, really we're just talking about using artificial intelligence to help you build, operate, and troubleshoot your robots better. And just about us. So Shouheng and I are veterans of the self-driving industry. We worked at Uber ATG, Aurora, and we're currently at Model Prime, where we're trying to solve the robotics data problem at scale. And we got to thinking recently about the state of the tool chain and how we could help the industry as a whole. And really, there's one maxim in all of this that I think all of us will understand, and that is that robotics is hard. We've talked about earlier in this meeting, somebody said that this is a hobby that takes 8 hours a day. That is the truth. And if you are, trying to do it at the industrial level, it can take 8 hours plus, I'm sure. And we've seen that. So we were just thinking, how do we make all of this less hard? And really, while we're thinking about this, there's other things going on. And we think that there are better tools needed to solve the problems of the next 10 to 20 years. And we've had a lot of things sort of happen, and we've had some holes in sort of like the offerings that people have and the tools that people can choose from. The first, that there's a lack of open source tooling for things like analytics, events identification, troubleshooting, and even making data pipelines. And there's been unleveraged AI advancements in the space. So things like LLMs, like ChatGPT, a RAG, retrieval augmented generation, and MCP, model context protocol. Um, and there's no native integration. There's no sort of integration point to get your LLMs to talk to your physical data. And there's no unification of these tools. So the community always comes up with really great packages for things like calibration, motion planning, et cetera. But there's no sort of tool that can, no unifying spine that those things can plug into. So a lot of those packages uh, don't have the impact in the industry overall that we would like to see. And these problems just are going to demand more from all of us. And the conclusion that Shouheng and I reached is that we need ChatGPT for physical data. And what that was going to include for us was four principles. The first is that we had to leverage AI. That one's pretty obvious. The second is that it had to be edge first. We've seen this firsthand at Model Prime. A lot of data gets created at the edge, and moving it to the cloud, if you want to do analysis at scale, is very, very difficult. And if you're, working by yourself, a lot of times you're not using the cloud at all. So us giving you a cloud-based service is not really helpful. And the third principle is that it had to be open source. No one was ever going to run anything on their robot that was not truly open source. And the fourth is that we had to provide full cycle support. And that meant that almost anybody in a robotics organization could use our tool at almost any point in the development of a robot and find use in it. And we're going to show you what that looks like. So let me go ahead and bring up my prompt. Can people see my prompt? Cool. So we have a PX4 log here, and I'm just going to simply ask Bagel to summarize it. We're going to summarize the metadata of this log. And what we're using here is we're using Model Context Protocol, which is a standard built by Anthropic. And that all that is doing is just giving us a way of interfacing these LLMs with physical data, in this case a PX4 log. And here we have the metadata of that log summarized. You can see the runtime, you can see the size, you can see the hardware that it was run on. Very cool. But let's say we want to ask a slightly deeper question. We want to ask if there were any errors or warnings in this log. We can ask that question too. And we can see here that we did have some warnings. And the nice thing is, if you actually ask it, hey, how could I deal with some of these warnings? It will actually give you steps. Now, what we're hoping to do in the near future is implement that with retrieval augmented generation, so you could upload the manual for your robot or any other internal documentation you have and get a more customized answer back. We're working on that right now. And if we wanted to ask, let's just say, I know that sometimes people want to know, does this drone need? We can ask whether this drone needs PID tuning. And we can see here that no, we don't need PID tuning. And the nice thing is when you ask sort of a qualitative question like this, not only will it give you an answer back, but it'll also give you the raw data. So you can actually make sure that whatever the AI is saying matches up with, your eye test basically. And if we're going to want to get like I guess, an overview of the topics in this log, we can do that as well. And it is, I mean, from the tools I've used in the past, being able to interface with your data in natural language just is a lot easier. And we are working to get these return times down just a little bit here. And I know Shouheng's been hard at work at that. So here you can actually see all the topics in your log. And what I'm going to ask it here is that to give me the average latency in this vehicle IMU topic. And there we go. We can actually get what the latency in that channel is. And the nice thing about this is what we've done here for calculations, one of the biggest pieces of feedback that we got when we brought this to the ROS Cloud Working Group was that people didn't trust LLMs for math, and there's reasons for that. They're not deterministic. And so what we did was we built a system where if you ask it a question that's based on a calculation, like what is the average latency in a channel, we'll take the user prompt, the topic schema definition, and we will create a DuckDB SQL query. And from the Robolog file, we'll actually create an ad hoc DuckDB table, and we'll get you an answer. And this result is deterministic, and you can actually have the data written out and the query so that you can actually validate the answer, so that you weren't just trusting the LLM to give you a calculation. As far as what's next, we want to support more LLMs. We're working on an OpenAI integration right now. We'll support Llama pretty soon, and we do currently support Cursor, and we're working on VS Code that should be out by the end of the year. As far as MCP tools, we want to create more sort of toolkits around troubleshooting, anomaly detection, calibration, and model integrations. We also do want to give you the ability to control your robot with natural language, but we want to be very, very careful about how we implement that. We do have industry partners using Bagel, and we just want to make sure we're keeping safety in mind and other things in mind when we do that access control, things like that. As far as integrations, we want to support more robot formats, and we do want to get a PyPy package out so that you can just pip install Bagel relatively easily. And we've been rolling. We launched in the middle of the summer. We have 320 plus GitHub stars. We've showcased this to many robotics companies who've been very excited and have informed the roadmap that we showed you earlier. And we're supporting more and more formats seemingly every single week. We now support ROS 2, ROS 1, PX4, ArduPilot, and Betaflight. And our Discord server is growing, and we'd love if you guys would join. The link is in our README, and that is linked by the QR code that we shared at the beginning and at the end of this presentation. As far as building new capabilities, that's very easy in Bagel. So what we started using was something called Pommel, which is a prompt-oriented markup language that's been pioneered by Microsoft. And what that lets us do is it lets us, in natural language, specify what we want to do stepwise in order to build a new function. So here, what we're actually looking at is the latency function that I ran at the end of the demo there and how that was built. So it's really easy to build new functions. And we went this route and investigated this route, I should say, because we wanted to make sure that nobody got blocked on needing new functionality. And if they needed something new, there was a way that people could unblock themselves very, very easily, or just build whatever their heart desired very, very easily. And the reason we're here is that we want to build a community around this. It's going to take a village to really build that next generation tool chain. And there are many ways in which you can contribute. The first is that you can obviously start our repo on GitHub. We would love that. You can file an issue or open a PR if you notice a bug or there's a new feature that you want. And you can become a contributor. And if you want to do none of that and just fork Bagel and go on your own journey, we'll support you as best we can. And our contact info is up here. We'd love to hear from you, and we're happy to take questions.
You're ready for questions now?
Yeah.
That was very quick. So what kind of hardware is required to actually run this? My old machine probably won't run it, but I'm considering buying something that with my very limited budget that might be used for this sort of stuff. And I'm just curious if you have any advice on that.
Not at all. I mean, it's running on my laptop, so no special hardware required. And
well, yeah, but like, what's your laptop? I mean, mine is like 5 years old, so.
I mean, as long as you can run Docker and allocate some CPU to the Docker image, I think you'll be good.
Cool.
Yeah. So
none of our laptops, I don't know about Shouheng, I don't know about yours, but none of the laptops I've run it on here have dedicated GPUs. And I have run it on something like a MacBook Air as well and not had problems.
So yeah, we don't really host the large language model ourselves. We're interacting with, let's say, Cursor and ChatGPT and the cloud. So yeah, there's no local hosting.
So the local computational load is pretty low then, is what you're saying?
The reading on the querying of the data happens locally, but the reasoning of it's done by the large language model.
Oh, that's okay. So that's a really important point that I had missed, because that makes a huge difference. So this isn't. So in other words, it's not self-contained. You'd need to have like like if you were doing a mobile robot or something like that, you'd need to make sure that you still had a connection. And really, this is primarily being used for. Is the focus on like understanding the data that happens after a run? Is that the point? Not for like directly controlling the robot.
That's right. So at the moment, we're focusing on what happened after a run is created. We can help you to debug and troubleshoot your robot logs. But there are progress in the large language model side. For example, there's GPT OSS, where it's a small model that we can deploy. But meaning small, you probably couldn't really deploy it on your drone. Still requires some CPU cycles. So but that way we can maybe integrate Bagel with like some robotics control and go from there. But yeah, Arun, do you have any thoughts on this topic?
No, I think you covered it really well.
So that's a great approach. I mean, so many of the things that I see are like, hey, give us direct control of your robot with this LLM and with this vision system, and it's all going to work just great. And then it hallucinates and does crazy stuff. So it's a lot better to like start from
Yeah.
like helping the human kind of a thing. And I love the approach of like letting the LLM help you code up something and then let an actual calculation engine like run it, as opposed to just letting the LLM hallucinate numbers for you.
Yeah, we try to
So what is the sort of the future direction that you are going to take in terms of like, what's the next thing that you're going to take on?
Yeah, so the first thing is when it comes to the calculation bit, we try to think of the LLM as a interface point for deterministic computation, as opposed to directly using the LLM for computation. And the one of the things that was said to us early in our journey when we first presented this to people was they said that the second L in LLM was very problematic, which is that language is not very precise. And we really took that feedback really seriously. So that's why we, at least for now, have sort of until we can be really, really thoughtful and sure about what the interaction model is and what the outcomes will be, we've sort of strayed away from the control aspect for now. As far as what's next, there's a lot of stuff. We still think that the implementation of retrieval augmentation to sort of merge documentation to give people custom or more customized responses is is something that we think is a big unlock. And really, when it comes to sort of like a larger ecosystem, we would like to affect even things like CI/CD simulation, all of that, with sort of like Bagel as being sort of like a central point for all of that, and really to create leverage for all of you. For the things that you guys do in that 8 hours when you guys are tooling around, we want to see if we can make that feel like you worked for 16 hours, get the output of 16 hours with just 8 hours. And that's really what we're focused on. Did that answer your question, James?
Yeah, it absolutely does. Connor had a question in the chat. If asked something like, give me a timeline of events, would it be able to detect a crash, takeoff failure, etc., or would that just be dependent on the quality of model used?
We have actually done that with some of our drone partners. They've given us logs, and we've asked those exact questions, or at least the timeline of events. Was a crash detected? All of that, and we're able to do that today.
So let me add more colors to this. If you just coming out with a very generic question, right? What event in this log? It probably will give you a pretty generic answer. However, if you're providing it more like more data to prompt, for example, right? Hey, I know that there's something wrong with the propeller vibration. And can you check if the acceleration or IMU data is normal, or do we have a hard landing from the IMU acceleration data, right? If you're being more specific on the data you're looking for, it will give you a much better answer.
So I guess I would wonder, like, you gave us examples related to like flying drones. There are obviously a lot of other types of robotic platforms. I think this group mostly works with like mobile robots, or at least that's been a big focus. And so I'm kind of curious, like, not just like about mobile robots, but like in general, what's required to get Bagel to work well with data from another platform? Like say I was working on a robot arm. I am, but or what if I was working with a mobile robot or whatever, and the log file is in a different format, or the information is fundamentally different, right? How do you adapt to that, or what is your input for training data?
You bet. So I can describe our methodology. So at the end of the day, they are all sensor time series, right? And for all sensor data, most of the time they are all highly structured. If you think of a topic of, let's say, IMU data, and basically it's a dictionary of dictionary. It's a nested structure, and we can apply the same principle to teach Bagel to understand those nested structure, and then cast all of those messages into a Apache Arrow table, which is a data format like CSV, roughly speaking. And at that point, Bagel can take over and understand that data and using DuckDB to query it. So to onboard a new format, robotics format, it's not difficult from our perspective. As you see here, we are supporting almost most of the drone format and the ROS. And if you have a preparatory format, as long as is like a structured data, Bagel can ingest. And I think there's still some work that we need to do to build an adapter to read those data, but that maybe take maybe 1 or 2 days.
So that kind of ties in with a philosophy that I think is really cool. So what I've seen a lot in at least in the early days in robotics with AI is this idea that, well, we'll go end to end. We'll do like just take the pixels from the camera and shove them into a neural network, and then the output of the neural network is the drive controls, and that killed people. And then companies like Waymo were doing like a bunch of processing on that data, and then like using more traditional methods of image recognition or segmentation or motion detection or hub transforms or whatever in order to extract lines, and then taking that information and feeding it into a neural network. And so you guys are doing kind of the same thing, right? In the sense that you're taking the data that's coming in and you're processing it first through this I forget what the name of the format was that you were talking about.
Sure.
And then you're
Arrow.
feeding it into the neural, and then you're feeding it into the neural network, right? So that you're not just trying to go end to end.
No, going end to end, it's difficult because most of the large language model are trained on text data, right? I mean, to my knowledge, most of them doesn't have a good understanding of, let's say, arrow format, because you have to deserialize it. And serialize and deserialization, I don't think, maybe I'm wrong, but maybe, but I don't think large language model can handle that very well. So yeah, we are preparing your robotics logs and cast them into the arrow files. And then we interact with the file using SQL queries that is powered by DuckDB, and the SQL query is generated by the large language model. So what we're doing differently is that we're gathering a lot of the context of that data. And what I mean context is that if you think about the schema of the data, I explained the nested structure, right? The type of the field. And sometimes you'll have like a field definition and the unit associated with that field. And then we take that information, we ask large language model to write up a DuckDB query, and that's how we analyze the log.
So I just want to add on to that really quick. So let's say, for example, that your large language model generates a query that has some kind of a syntax error in it, or it hallucinates something, or it's wrong, right? And I'm assuming that can happen. Then do you have some kind of a mechanism for then directing a correction like can it read the error message and then try again and go around in a loop on its own without a human having to mess with it in order to correct it?
Yep, we can. However, that's not from the Bagel side. That is the advancement on the large language model side. They have this chain of thought, and then if there's let's say you made a mistake on the generated DuckDB query, and it throws an exception, right? You were able to take that exception and add it to the context and reprompt it to generate a correct DuckDB query without you basically doing everything. So in terms of the accuracy of the query, yes, it could be hallucinating. However, from my experience, it's mostly okay. But there is a safety mechanism, which is the human in the loop part. It prints out the DuckDB query, SQL query, before it runs it, so you can manually inspect it, whether it makes sense or not. I guess that's our approach.
So there's a question in the chat, but I just wanted to finish off this thread with one more question or comment. So this is a really exciting approach, and I think it's a really responsible way of using AI, and I really appreciate what you guys are doing with this. What I've seen is there's a particular professor whose name I'm not going to be able to think of right now, who has done some work with this. But part of the problem is, like, if you're just using an AI in a robot control loop, how do you know that the input to the robot is wrong, right? You need some way of like checking it before you actually tell the robot to do it. And so one of the things that this particular professor has done is worked with PDDLs such that the LLM generates a very high level concept of like, these are the actions that I think will get us from this, from the current world to the goal world. And it runs that very, very quickly, because PDDLs are great for that. They can very, very quickly analyze that something is, yes, these actions do result from these changes. And then potentially, if it passes that, run it through a simulator, a physics simulator, in order to verify that, there aren't a bunch of collisions or unexpected things or, whatever. And then if it passes that, then actually try it on the robot. So it seems like you guys are kind of moving in that direction. And I think that's really wonderful. So I'll let you respond.
Yeah, one of the
things. Chat, there's a question waiting.
I guess let me just briefly comment on that. Right, Arun and I were sort of paranoid about adding the robot control in Bagel, because we don't want, as you said, right? We feel like it's very irresponsible just to let large language model to generate a motion planning, let's say plan or set plans, and just let it rip, right? We are still thinking about there are a lot of aspects that we need to consider. For example, permission issue. We just can't let anybody in the organization to issue command, right? That need to be on a permission. We had to have a permission layer on top of that. The second one is that we have to have guardrail policy that is deterministic. For example, don't go into this area and don't operate if you see a warehouse worker, right? Something like that. And those policy couldn't really depends on a probabilistic programming like a large language model. It has to be hard boundaries. And we're thinking through this problem. That's why we haven't target the control aspect first. So yeah.
I think you found a real sweet spot to start doing this, and I think I'm overjoyed to hear that you're thinking about that and that you're moving in that direction. Because so my response to that would be that if the LLM is coming up with a motion plan that has passed through some kind of quick check and then has passed through a simulation check, then at that point maybe a human being can take a look at it and go, oh, well, that plan worked in the simulator and I like what it's doing. That makes sense. Looking at the simulation, looking at the visualization of the simulator, and then they can sign off on it, and then that's giving your LLM and your system, what's the word I'm looking for here? Plausible deniability, is that the right political term? To say, hey, it wasn't, the LLM didn't do it on its own. The human being, approved the motion plan that destroyed your factory. So yeah, I think that's great. And I think Terry had a question about how many data runs are required to get accurate information.
So you can just like jump in on Bagel without, with zero shot. The accuracy of the results, it's really about how you craft your prompts. Arun, I think, have a previous slide about like how do you develop new capabilities using the POMO language and the POMO file. So if you are very specific and very careful and concise with your instruction, usually yields a reasonable results. And yeah, so it doesn't require data run to train, so to speak, but it requires clear instruction.
And one thing I will just add to that is occasionally you will have to ask a second question or a follow-up question. It is kind of cool in some ways to just kind of have a conversation with your physical data and ask it questions and then ask it follow-ups. But if you don't want to wait or you want a shorter conversation, just being a little bit more specific with your prompt certainly helps.
Well, I was still, I guess what made me stumble a little bit on this is that didn't you have a prompt that asked for the accuracy of the errors earlier in there? And I was like, how can you get an accurate value of what is in the good range versus the bad range if you don't have enough statistical data in the number of repeated runs that it can use to calculate it by? So
Yes.
if you only have 2 runs, your average is an average of 2. That could be a really poor data set, if you know what I mean, mathematically.
Yeah, so I think there's a couple things. So first of all, you're using like the logic from your LLM provider in that case. So either an OpenAI, a Claude, or a Gemini, or whoever, and those tend to be pretty good. But the other thing and I think this is something I made it a point to sort of talk about, is that it will also show you the data from that run to make sure that whatever conclusion it reaches also passes your eye test as well. So as much as possible, like we do know that these tools are imperfect, and so and I think James put it really well. We're trying to sort of like give the human more power, give them more leverage, but not take away human judgment in this space. We don't think the technology is there yet.
Okay.
So if I can elaborate a little bit on that, roughly I think about this problem as how do you define normal, right? Given the most recent run, the most recent log data, it's really hard to define normalcy in the long run. You probably requires a month of data or the runs for a particular software version, right? So yeah, so I think that's a limitation of this tool at the moment. It can only tell you the information of this particular run. However, if you have that information, let's say in a dashboard or somewhere else, and you understand the baseline normalcy, and you can instruct the Bagel, for example, hey, if the vibration is outside this band, then this is abnormal behavior.
Right. I mean, if you forgive me because this is still fairly new for me, but if you're, I suppose if you're collecting the data sets and you put the tolerances in the data set itself, then it can make a qualitative assessment even with just one run of data.
Yep.
But if there's no, what I didn't see in your previous prompt didn't help me to see that, whether or not it had been fed tolerances on those values. It just spit out an answer, and I was thinking, that how do I know that's accurate? kind of thing.
Yeah, I mean, at that point, like I say, us printing out sort of like the relevant parameters there and showing
Yeah.
them to you and letting you use your own judgment is still we still think that there is a large place for human judgment in all of this. Again, these tools are not 100% perfect. We're hoping to give you leverage and hopefully reduce your workload, but there's no substitute for good judgment, unfortunately.
Yeah. And by the way, I think this is a fascinating development. I do think this is a terrific idea. I just was trying to understand how you can build in the accuracy in it when you're using it so that you're getting good results, what you're looking for.
We do think that retrieval augmentation could also help there if you can feed it sort of like data from previous runs. It would help contextualize the answers based on data that you fed in. We don't have that working yet. It's on the roadmap, but we also think that's another path to maybe getting that to a better place.
And another potential project we've been thinking about is to let you to develop a set of boundary and policies. For example, after I have a robot log run, and if the, let's say, acceleration is beyond this level, right, then tell me that there's something wrong with it, right? You can have a set of triaging requirements in this document, and you can just feed in the document, feed in your log, and then it will run the triage for you automatically. And you don't have to run any C++ code or Python code to do it. You can just describe what you want using natural language. That's another thing that we're looking into.
Neat.
This might be a dumb question, but could something like this also be used to assist with decoding a proprietary serial interface?
My internet is dropping off a little bit. Decoding, could you repeat that again?
Yeah, so decoding a proprietary serial interface. I've got a serial interface that I've captured logs with using Sele logic, and I can export those logs to a series of CSV files. I'm trying to determine what logic is being sent through the serial interface to control certain functions on a series of hydraulic proportional directional solenoids.
So if you already can deserialize the binary data into a CSV file, I mean, just if you're willing to share the code, I can build an adapter in Bagel, and next time you have those binary file, you can use Bagel to interact with your data. So I don't think Bagel or large language model can just decode any unknown binary format without any prior knowledge of the structure of the data. But if you already have the deserializer, it can be integrated into Bagel.
Well, I may follow up with that. I've got to collect some more logs with some additional parameters, I guess. But I've been challenged with trying to get this done.
Yeah, you bet. I mean, let's talk. I mean, if you have a binary format and you know that you want it into a more ingestible format like a CSV or JSON, and you're just missing the deserializer, and let's talk if you know the format of the binary log.
Great. I'll follow up. Thank you.
Yeah, you bet. There's another comment.
Oh yeah, sorry, I was just responding to Craig offline then.
Oh. Yeah.
Thanks, James.
Yeah, I appreciate you guys working on this. This has actually motivated me to put ROS2 on my larger robot. I've always avoided it, and I know there's a ROS2 CAN bridge, but my entire robot communicates through CAN, and there's not a lot of motivation to switch to IP because it's, I just haven't needed to. So in ROS 2, well, there's a lot of plugins and utilities and whatnot. I haven't needed anything that ROS 2 really offered until this, like being able to log, which is always a problem in robotics, especially, I mean, I know all robotics, but certainly in hobbyist robotics, if you're trying to record, why did it do that? Why did it just veer off that way? Was it IMU data? What was going on? That's probably like my biggest, the thing I lack the most in my robotics is logging and interpretation of that. So this is motivated me to invest some money. You guys just cost me money today, so that I could maybe prepare myself to ingest that. So
Maybe we can start a GoFundMe to help offset it. Yes.
yeah, I'll live. I'll do all right. But I appreciate it. This is fantastic. What a great tool.
Yeah. Look, reach out to us. You can join our Discord server if you don't want to email us, but
Yeah.
stay in touch. And even if you just want to reach out to us on LinkedIn and just send a connect, we'd love that.
Perfect. You guys have a link to your Discord server?
It's a few.
It's in the repo.
It's in the.
Oh, it's in the repo. I
it's in the
already
repo.
started your repo, so I'll go look at it. So,
Thank you. Thank you for the start.
Yeah.
Can somebody post a link to the repo in the chat? I don't have a way of. Oh, there it is.
Oh
Couldn't
yeah,
even
sure.
find it in a minute. It's github.com/ yeah, that one. Thank you. Yeah.
cool.
All right, guys. That's pretty much it.
All right. Yeah, thank you for
so
presenting.
much.
It was fantastic.
Did you need to leave? Okay, great. I really appreciated the presentation. I thought it was really wonderful. I just wanted to say thanks.
Oh, thanks so much. We put a
Yeah,
lot of
thank
work
you.
into it.
It was very action oriented.
Yeah, it's a labor of love for both for Shouheng and myself. So it's really great to see the reaction that people have to this, especially when they see how much work it can potentially save them.
Yeah, for sure. Anybody have anything else for them, or?
I guess I did have one other question, and that was if you were, we've been talking about working with data that's uh, in logs, it's more numeric in nature, but what if you were using video navigation and you're feeding it images? Does it
That's
have the ability to interpret any of that?
That's a great question. I played a lot. We dabbled into this, which is I guess was called video language model, right? So we take a camera feed from the robot, and frame by frame, we encode that into a vector embedding, and then send the vector embedding to the large language model to interpret that. For example, hey, do I see a pedestrian in this frame, right? So we have some moderate success on the task of object detection, semantic captures of a frame, and I haven't tried we haven't tried the segmentation yet, but the problem is that it requires you to have a beefy GPU, which I don't have. So
Yeah, I could understand that.
But yeah, so I'm doing everything on top of my CPU, which is like painfully slow. But we have some prototype on top of it. It's on our roadmap. We just don't know how to make it into I guess, a consumer-friendly version without a large cloud build, right? So, but yeah,
Great. But yeah, good luck. Good luck with moving that forward. And by the way, I did want to say I think it's fantastic you made it open source so that it's really available to everybody. That is very much appreciated.
Yeah,
Yeah,
and I think, like I said in the presentation, the real motivation for that is just we didn't think anyone was going to be willing to run anything on their robot that wasn't open source and something that they didn't trust, and we thought that that was the best way to build trust.
Mhm.
I think you're muted.
Definitely
Oh.
muted. All right. Unless there's any
Okay.
other questions, I'm going to stop the recording.
Okay. Thank you,
Okay,
gentlemen.
great. Yeah, thank you.